Nation, another glorious day here. I got my buddy Brent here. We're going to talk about some more. Wait. This just in. I got to kick it to the guy in the field.
Hey guys, I just watched 2 trucks back to back get rejected for high slump out here in the field.
Slump issues.
Yeah.
Contractors mad.
Yes.
Test man's not happy.
Yes.
How do we fix it?
Well, it depends. If it's high slump issues, one thing. If it's low slump issues, it's another thing. If it's inconsistency truck to truck, that's a totally different animal. So let's, yeah, so.
Well, inconsistency could still be within slump tolerances, things, but.
It can be, yeah.
And of the ones that we generally were worried about, the higher slump issue, from a testing standpoint, was always the one that we were looking more at. The low slump issue is more of a finisher yelling and screaming. So
yes.
But let's start with the one that, from my days of yore, back in the late 1900s when I first started.
Yes.
High slump.
You're old.
You're not much younger than I am.
Oh yeah, like a month or something like that. So high slump is a little bit more of a concern, just simply because in the course of my career, I saw way more loads get rejected for high slump than I did for low slump. That's not to say it can't happen if you show up on the job with low slump. There are some contractors, some owners that want it to show up closer to where it needs to be. But high slump really, when you start having slumps higher than expected in the field, there's kind of an order of the way I used to check it, and it was helpful to me to think of it this way. Number one thing I'm going to do is check water sources. The water sources that are outside your batch water that you're intentionally putting in the truck.
Right. Not the ones that the finisher's doing, but the ones from the plant.
Right. So I would always start with the plant because I wanted to be sure that when I engage with that concrete finisher that I've covered all my bases from a production standpoint so that I have the answers he's looking for from my end. And sometimes it would be a situation where we had something that was off, like a sand moisture. If you're adjusting for 4% free moisture on the sand, but it's really running 7, that can make a huge difference in the water content in your load of concrete that could lead to higher slump. Things like water left in the drum when a driver comes back from a previous job. They wash their fins down a lot of times and they don't want to get built up in their trucks as they should, but sometimes they'll bring water back in the belly of that drum and not tell anybody or not reverse the drum, and that becomes an undocumented water situation in that load.
Just out of curiosity, how did you ever find that?
Really came down to on projects that I was involved with where you had a water to cement ratio that was very important for durability or something like that. We would make the drivers or ask the drivers to reverse their drum before they backed in.
But you're saying, if I've got a job that's got this requirement, I'm making sure they do it.
Yeah.
But if you're troubleshooting, how do you catch that that's what the driver did if it's a load here, a load there, or if you just start getting them all over the place, you're just going out going, hey guys, make sure you do this?
Yeah, so unfortunately, the only way to know if they had water on the drum, just 5 or 10 gallons or whatever it was, is to ask the driver, did you reverse your drum after you wash it? And sometimes they'll be truthful, sometimes for obvious reasons, so they don't want to get in trouble. They may not tell you that.
What?
Yeah.
Surely not. That never happens.
Yeah. So I found that the best policy was always to try to have the drivers reverse their drum as they're backing under the loading chute. And that way you're sure that drum's empty before you start dropping a new load into the truck. The next, so the undocumented water is the #1 cause of slump being high, whether that's in the truck, in the sand, you might have a wet rock even, or it could be, as we've mentioned in previous videos, wash rack. Where a driver's trying to help out, they think this particular, he gets it on the wash rack, or he or she is looking at a 4.5, 5-inch slump, and he knows that particular finisher wants to place the concrete on a 7.
Happened many a times with me as a test man, like, why is this so wet? Well, the finisher likes it that way.
Yeah, so the #1 thing to get a hold of is those I don't know if you want to call it extraneous water or the water that is not accounted for in the batch computer. That's the #1 place to start. And then if you still can't make sense of it and you've got an account of all your water and you're still having higher slump issues, be aware that your water reducers may change effectiveness depending on the season. So, and as it gets hotter, your water reducers aren't as effective at holding those slumps for as long as you'd like. So it may be time to look, or they could be in the cooler weather. Let's say you're running along with a particular dose in the summer, and it starts cooling off like it is now as we're filming the video. It's in
This is a joke. This is a false coolness. Do not believe it. It's coming back. It's coming back with torture.
I know. It's in the 70s and 80s this week in Chattanooga, and it's really pleasant. But we know it's just August when we're filming the video, so it's going to get hot again. But as the temperatures cool off, that water reducer may become more effective and cause higher slumps, which is a much better problem to have than high water, because you're not going to hurt your strength or other properties of the concrete from the water reducer, typically. So that's the main issue surrounding high slumps. Low slumps, if your slump's lower than expected, again, you're going to want to check your sources of water to make sure you're compensating for the correct free water in your ags. You're going to want to also, with low slump, make sure that the coarse aggregate, especially that you're getting in, is clean. I've ran into some poorly washed coarse aggregate situations in the past where those fines, the -200, causes that water demand to go up. Right. Yeah. So if your aggregates begin to get finer, it can cause that water demand for a given slump to be
right. And just for sake of conversation, the reason we want to know, because a lot of people are like, slump's low, it's not that big of a deal. But if it is that aggregate stretching it out, it's also stretching your cement out, which could create other issues that we'll get into later, but just something to consider. Just a lot of people get focused on the high end. The low end can be just as much of a problem.
Yeah, your cementitious is covering surface area of the aggregates, and if there is fine material in that aggregate, more finer than expected, then it's going to have more surface area it's got to coat, and it's going to spread that cement out. So yeah, exactly right. High temps can also cause water demand to go up. So we previously discussed in another video about know the job that your trucks are going to, and sometimes that may require things like a hydration stabilizer to retain that slump so that contractor's not having to add a bunch of water. Long transit times can also cause lower slump issues. You can have more slump loss on the way to the job the longer you're on the way to the job. Lastly, I wanted to mention that in the consistency of slump truck to truck is something that will pop its head up from time to time. And that's a real pain to a flat work finisher. If they've got a 4 and a 6, a 4 and a 6, a 4 and a 6, then they're having to worry about, well, is this area of the slab going to set up faster than this area?
Right.
So consistency in slump, getting that control over the wash rack is probably #1. #2, for things I've run into, is make sure that your mixer truck blades are clean and they don't have a ton of buildup, because some of that can cause slump variations. And also, the last thing, you and I discovered this one time, we'll be sure to tell this story at some point. The last thing I wanted to mention is mixing versus transit. If you got a driver running to the job and he's turning his drum too fast or too slow, it can impact the slump on the job site. So standardization of the speed that agitation speed is for your crew.
That, in a sense of urgency, not stopping and getting a steak dinner on your way to the job site helps on that slump retention as well.
Absolutely, yep. That's a common cause is oh yeah, this guy stopped for 45 minutes for lunch or something, and then especially in hot weather, that's
a whole different troubleshooting there.
It can be a different ball game. So that's it for slump issues. If you have any questions or comments, please stick it in the comment section down below, like and subscribe, and thank you very much for tuning in and seeing what we have to say about the QC stuff. We're continuing this QC series for the next several videos, hopefully. Thank you. Join us next time for air issues.